all of you. Today's topic is the preparation of isoquinoline. Method of preparation of isoquinoline is done by the special Bisler-Labraski synthesis. And the step involved in this are the three steps, mechanism parts. First step is the condensation of the benzaldehyde with nitromethane in presence of the base to give rise to the first intermediate. So in the first reaction, that is benzaldehyde and react with the nitromethanes. There is addition types of the reactions. CH3 groups of the nitromethane is acidic groups, and on the arrow condition is the base. So base abstract the protons in this case, and after abstraction of the protons, means here is the CH3, one hydrogen is there, CH2 means CH3, and this is a NO2. So in this case, hydrogen is the acidic hydrogens. Hydrogen is the acidic hydrogen. So these acidic hydrogens in presence of the base can be easily abstractables. If we see the acidic strength of the NO2 adjacent carbon hydrogens, so we find that NO2 is the most electron withdrawing groups. So due to this most electron withdrawing groups, CH2 having the three hydrogens, the three hydrogens are very acidic. Means it can be easily give the H plus ions, and whenever weak base can be used for that also. So by using a weak base, we can easily lose the H plus ions and form the carbon anions. So after removing this CH2, it becomes CH2 minus NO2. CH2 minus NO2. After meeting the H plus ion, it becomes CH2 minus NO2. This is act as nucleophilic attacks because this is in resonance with the NO2. So it is a strong attacks. It can give the resonance here, and the NO2 is present in the form of NO minus. So resonance structures is good in resonance structure. So it can be easily form the carbon anions, and that carbon anions is more strong. So this carbon anion react on the which it react on the this benzaldehyde carbon atom is the more electrophilic in nature. So this CH2 minus can easily attack on the benzaldehyde carbonyl carbons and form the new bonds, and that bond remove the H plus ions and gives the alkene systems. So this is the one of the first intermediate of these reactions. So we will get the first intermediate like this. This is the benzene ring. In the formation of this new CH2 added. Here is the NO2. That was the C double bond O, which loses, which we are loses. So therefore, if there that if we loses this oxygen atom in the form of OH, then we will get the double bond in replacement of that with the formation of double bonds is a NO2. This is the first intermediate of the reactions. Now in the second step, step seconds, reduction of the nitro groups takes place. The second step, reduction of the nitro. In the second step, reduction of the nitro takes place and form the beta phenyl ethyl amines and form the beta phenyl ethyl amines. So reductions or the reductions is the already NO2 groups. This is done in the reduction by using lithium aluminum hydride, the strong reducing agents that reduces the double bond and converted it into the NH2. Into the NH2 beta phenyl ethyl amine of the product. Bond also loses. So step, this is step second. In the step third, what happens? This NH2 react with the acetyl chloride, means acetizations of the beta phenyl ethyl amines, followed by heating of PCl5 under the given conditions and the cyclodehydration to give the 3,4 dihydroisoquinoline is the final structures. So what happens? The intermediate reactions are given. This is the one step. Here we form the NH2. Now NH2 to nitrogen having the lower pair of electrons, so it can be acted as a nucleophile. It will be react with the RC double bond O Cl, means acetyl chloride. Means this will be attack on this carbonyl carbon and this group is leave from this reactions. Means this nitrogen atom will be joined. I will show you how it is joined to the joint of these reactions. So now we react with the C double bond OR in this way. So if it is right in proper way, so we will get the structures like here C double bond O R is the structures. This is the steps. Now this is react with the PCl5. If it is react with the PCl5 form the cyclization of the rings, means rings formations takes place. Means these rings joined by this way, so we will get the two rings, cyclized rings. One is the nitrogen ring, another one is the this rings. So this is the cyclized ring and here is the R group. So this is the first intermediate. This is the first intermediate of these reactions. So now this is not the isoquinoline because here is the one double bond is absent. What it is need? If it is present in the structures, then there is a formation of the aromatic structures. Means the structure get the aromaticity, and as it get the aromaticity, means the stability of the structure increases. So that is why we have to proceed in one another next step. So in the next step we will find out the reactions will. So how we can form the double bonds in this case? The structures is given. The structure is given. This is the structure. So we need to form double bond here. We need to form double bond here. We need to form double bond here. So how we can form double bond here? This is the question. So we can form double bond here. Here is the hydrogen atom. Here is also hydrogen atom. If we remove the hydrogen atom from these two sides, if we remove the hydrogen atom, from these two carbon atoms, if we remove the hydrogen atom from these two carbon atoms, then we can easily form the double bond here. If we remove the hydrogen atom from these two carbon atoms, then we can easily form double bond here. How it is formed? Because to make the stability and replacement of these hydrogen atoms bonds, compensations takes place by the formation of new double bonds. So means the removal of the two hydrogen atom means actually it is the reductions. For reductions we use the reducing agents. That reducing agents is the palladium, carbon, and we supply some heat, that is 100 degrees centigrade. So palladium, carbons in the good reducing agents, it remove that two hydrogen atoms and form the bonds. So here is the palladium oblique carbons at 100 degrees centigrade remove that two hydrogen atoms and form the new bonds, form the new structure. That structure is, we will find out these structures. So this structure without two double bonds, here is the R is the form. This is our isoquinoline structures. This is our products. So in this way we can form the structure from the isoquinoline. This is a simple method to prepare isoquinoline. So important step is the first step. In the first step we react the benzaldehyde. Benzaldehyde is the first step. Here is the benzaldehyde. So you remind that how to memorize, how to many times practice. Firstly you have to remind the starting material. Starting material is the benzaldehyde. Starting material is the benzaldehyde. This is the benzaldehyde. It is the starting material. Okay, and step by step we are lengthening this C double bond. We are lengthening this C double bond OH group. Firstly we add this one carbon atom with NO2. So we added here in the first step, we added here CH double bond CH NH2. This is our first step. In the second step we reduce these structures by using the lithium aluminum hydride. So reduce means what happens is the CH2 single bond CH2 NO2 converted into NH2. Now in the next step we add another carbon atom into the rings, so that if the total number of atoms is the 1, 2, 3, 4, 5, or the formation of the ring will require the 6. So what happens if you write this in proper way, to be we will get the cyclized structures like first carbon, second carbon, third carbon, and the third carbon is the NH2. We need one carbon here, so that we can attach. We know the structure of the isoquinolines. We have in mind that how we can form. So we need a one. So for adding this one, we use the acetyl chlorides. So acetyl chloride added here. So we will get these structures in this way. So how we will get here converted into the NH. Here is the C double bond OSR with added for the addition reactions. Now by by using the acetylation reactions, by using the another groups, we will find out joining here. How we joins? We join these groups. Here is added R with the formation of C double bond. Now in the final structures, we have to add one double bonds means reductions required. For reductions, we use the palladium carbon. So finally, we get the structure. This is the final structure of the isoquinoline. In this way, you can remind the preparation of isoquinolines. So the friends, thank you. We will meet in the next lecture. We are going to study the next, that is the hydrogenations of the pyridine and oxide reactions, chemical reactions. We are going to study in the next lectures. So the friends, do the practice regularly of these mechanisms. Mechanism part is easy, but it requires the practice, and practice is only the key for the mechanism parts. So do the practice. Best of luck. Thank you.